Picture this, it's 1974. Philip C. Jackson Jr. stands on the edge of a digital revolution asking, can machines really think, not just follow orders, but reason, imagine, even play games like chess? This question isn't just technical, it's a challenge to what it means to be smart. But how far could computers go? Jackson peels back layers of early AI research, opening a door that will lead us from simple calculators to intelligent machines. Ready to step through? Jackson starts by grounding us in the earliest breakthroughs. How did computers get from crunching numbers to solving puzzles? Understanding the foundations clears the fog of complexity. In 1956, at the Rand Corporation, Alan Newell and Herbert Simon unveiled the Logic Theorist, a program that proved mathematical theorems. It wasn't magic, it was a machine mimicking human reasoning. Jackson highlights this as AI's spark, a moment showing computers could think in an abstract sense. Jackson compares human problem-solving to computer operations like following a map. Imagine you're lost with no GPS, your brain tries pathways that seem promising. AI tries to model this process by encoding knowledge and strategies, making computers not just number crunchers but decision makers, simulating what we call intelligence. The breakthrough: heuristics. These are rules of thumb, mental shortcuts. Instead of exhaustively searching every possibility, AI programs use heuristics to zoom into promising paths. Jackson reveals this as the secret sauce that powers efficiency, turning brute force into elegant, practical intelligence. Once machines could reason a bit, the big question became, could they grasp language, play complex games, or interact like humans? Jackson dives into these bold frontiers and the surprises they revealed. Jackson tells of early chess programs that knew the rules but initially failed to win. Then researchers developed heuristic evaluations. Machines learned to judge which moves felt stronger, mimicking human intuition. This wasn't just brute force, it was creating a strategic mindset inside machines. Understanding natural language seemed the holy grail. Jackson outlines efforts like ELIZA, which mimicked conversation by pattern matching but lacked true comprehension. This revealed an uncomfortable truth. Language isn't just syntax, it's context, meaning, and subtlety, making AI's grasp on communication a much tougher puzzle. Jackson pulls back the curtain on game trees, vast branching roads AI explores to decide moves. Through clever pruning and heuristic search, machines avoid checking every branch, focusing on promising futures. This algorithmic foresight gave AI a powerful edge, eventually leading to programs like Deep Blue decades later. Jackson pushes beyond theory. What happens when AI hits the messy real world? The shift to robots and sensory input rewrites the game, revealing AI's gritty frontlines. Jackson highlights early experiments with robotic arms that combined cameras and sensors to see objects. At Stanford Research Institute, Shakey, a wheeled robot, could navigate hallways and solve simple puzzles. This real-world embodiment forced AI to deal with noise and uncertainty, a radical leap from neat calculations on paper. Heuristic scene analysis is like teaching a child to recognize shapes and objects from messy images. Jackson explains how AI uses clues like edges, shadows, and textures to interpret scenes. It's an art and science blending fuzzy perception with sharp logic, a critical step from data to actionable knowledge. Factories in the 70s started automating complex tasks with AI-driven machines, from assembling components to quality inspection. Jackson shows how combining sensors, software, and heuristics created smarter workflows, reducing human error and costs. This industrial shift hinted at a future where intelligent automation would change every sector. Remember Jackson's question from 1974, can machines really think? We've seen the sparks of machine reasoning, the dance of language in games, and robots grappling with a messy world. Those early discoveries shaped today's AI wonders. So next time you use a smart assistant or play against an AI opponent, imagine the journey from Logic Theorist to now. Try this, spot a heuristic in your daily problem solving, and see how AI's secret weapon is part of your brain too. Subscribe for more book summaries like this one.